Okay, so now that you guys have done the angle side angle and the angle side possibilities, we're going to deal with the third type of law of sine triangles, and that is when you have an angle side side. So if we abbreviate, you notice, ooh, that's a bad word. So it's going to be a little bit tough and not so good because once again we have that bad word, so it's not good, because there are going to be three options that can happen when you have one of those bad word triangles. So you can either have zero triangles possible, like it's not possible to create or construct a triangle with the given sides and angles measurements. You can either have one triangle possible, or there are two possible triangles that can come about from that measurement. So that's the reason why we couldn't use angle side side as a reason in triangle proofs in geometry. Like you were never allowed to use that as a reason why for those triangle proofs. And the reason why now we know a little bit more is that there are three options of triangles. So we can't say that, oh, they would be, congruent triangles or anything like that. All right, so just this kind of recaps the types of the drawings where you would have none, what it would look like, and then where you have one triangle, and then the possibility for two. So I'm going to get into the possibility for two a little bit later. So I want to just kind of talk you through how I basically set this up. So if you have the side of the pair, so remember how above we were boxing in the one that was like A and A or B and B. So if the side of the pair that you're given is larger, so an L looks like a 1, is larger than the other side, then there's only one possible triangle. So if the side of the pair is larger, think larger, starts with an L, kind of looks like the number 1, there's only one triangle possible. If the side of the pair is smaller, then that's where we're going to have two options, either 0 or two triangles. And the way that it's going to be 0 is that there's going to be no solution when you calculate sine inverse. You're going to get either a domain error on your calculator, and the reason why is when you're doing the inverse of sine, it's going to be greater than 1, and we know that sine can only be between -1 and 1. So that's why we're going to be getting an error for that one. All right, so let's tackle this. This is where it's the two triangle possibility. So I'm going to just highlight this. We'll come back to this a bunch, but I just wanted to show you what it would look like. So if you are given angle A, and side B. So you can either have this triangle in green, or you could also have this outside triangle where you have the same angle A, B is the same, and A is the same length here. Okay, so those wind up being the same. All right, so I'll get rid of all those on there. Okay, so let's break it down. First thing, example 4. I'm going to just change it so I don't have a green pen while I'm solving this. All right, so setting it up, A, B, and C. All right, and then little a, little b, and little c. All right, so we are given angle A is 42 degrees, and then side B is 12 inches, side A is 22 inches. Therefore, I have an angle side. Ooh, bad word. So that means this is going to be one of those dicey triangles that I need to figure out how many possible ones are there. So I look at my given pair. Is this side A, which is in the pair, larger or smaller than the other one? So it's larger. So, all right, so A is larger than B. So therefore, there's only one triangle. All right, so that makes our life easier. So we can go ahead and set it up with the law of sines. So we do our 22 over sine of 42 equals 12 over sine of b. And I cross multiply. So I do 12 sine of 42, and that's 8.03 equals 22 sine of b. Now we're going to divide by 22, so I get 0.365 is equal to sine of b. So now we got to get rid of sine. So remember the way that we got rid of sine in the past is with sine inverse. So we're going to take the sine inverse of each side. Okay, so we do second sine, and then I'm going to do second answer to fill in that one on my calculator so I get it the most accurate as possible. So we get angle B is 21.4. Okay, so now I have 2 out of the 3 angles. I can do 180 minus 42 minus 21.4, and I get 116.6 degrees. And then I have to find C. So I'm going to go back to my law of sines with my original pairing, which is 22 over sine of A, which is 42. And we're trying to find C, so C over sine of 116.6. All right, so I'm going to go ahead, 22 sine of 116.6, and this becomes kind of like one of the other ones that we've done, divide by sine of 42, and we get C is equal to 29.4. Okay, and that is it for the one where the side in the pair is larger than the other side. All right, I'm going to just erase this a little bit so I don't get that in the way of my work right here. So that way, scrolling down, there we go. All right. Okay, so now we've got A, B, C, and then little a, little b, and little c. All right, so we got A is 85 degrees, little a is 15, B is 25. Uh-oh, I'm noticing it right now. I've got angle, side, side, bad word. So I look at that pair and I say, is that larger or smaller than the other one? So when I look at this, I say, uh-oh, A is smaller. Okay, so that means it's 0 or 2 triangles. All right, so 0 or 2 triangles when it's smaller. All right, so, well, let's see. If it's 0, it's gonna become apparent in my calculations. If it's not 0, then it's 2. All right, so I start off 15 over 85, sine of 85 equals 25 over sine of b. All right, so I'm going to cross multiply 25 times sine of 85. I divide that by 15, so I get sine of b equals 1.66. And now remember, to get rid of sine, we're going to do sine inverse of both sides. But right now I'm looking and I'm saying, hey, wait a second. Taking the sine inverse of a number that's bigger than 1, that's definitely not going to happen. So I can confirm it with my calculator, second sine, second answer to fill in that 1.66, and I get error in the domain because sine has to be between 1 and negative 1, and there is no value that would give me a sine value that is greater than 1. All right, so this is no solution. There are 0 triangles possible. All right, so there's no way we can create a triangle with that given set of measurements. All right, so I'm going to pause it here before I tackle the one that is much more complicated than these.